Oh, bam! This is not Teru. This is Mr. Weideman. This is our pre-calculus class, Lafayette High School, and we're going to talk about trigonometric identities. All right, I'm going to start off with just a real quick recap of what we went today. All right, we have all these little tools, these little identities and properties that we need to memorize. And we went through all that, and it says, okay, well, what are these things used for? What are these tools used for? Well, we use these to basically do some algebraic manipulations and substitutions. There are algebraic tools for proofs. And then I showed y'all how some of these tools are used in our strategies. And here's a real quick recap of our strategies. Convert inverse functions. Use conjugates is another strategy. When I see an addition of terms, I try to get a common denominator and add. And you'll notice that every single one of these strategies is using our tools to simplify expressions. And we're going to expound on that. Okay, so what we're going to do is we're going to talk about using these tools, and this is what we're going to do. All right, we use these tools to establish identities. They're basically proofs, which means I'm going to prove that something on this side of the equal sign equals something else on this side of the equal sign. Okay, for instance, all right, here's an example. This is a typical homework problem. All right, so I have one side, and it says it equals this. And we're going to prove that. And the strategy that I typically use is I like to start with the yucky side, the complicated side, and simplify it or show that it simplifies to this guy. Now, it is possible to do the proof the other way. I can take the right side of the equation and I can expand it and show that it equals the left side. That's usually much harder. Okay, we're a lot better at simplifying things than we are expanding things. All right, so that's typical stress. So I start with the complicated side. Now, every now and then you see two sides and they're equally complicated, so it doesn't matter. All right, but this side is clearly more yucky. Okay, and this is what I like to do. I like to express all of my trig function in terms of simple sine and cosine. And then I can quickly see my next move here. These guys divide out, and 1 over cosine is indeed secant. And so there, I proved that the left side simplifies into simply secant theta. All right, are they all that easy? Absolutely not. All right, let's do another one. And this one is pretty rudimentary. And this thing, usually your textbook says, okay, let's establish this. And usually it means just proof. Now this one's a little bit simple, but it has 2 points that I want to make. Okay, the first point I want to make, and we talked about this in class today, is this sine squared. Okay, that's literally like saying adding squared. It really makes no sense. Sine is an operator. And so to take the square of any trig function really means I need to square the function, not the operator in the function. So this is really what you need to think of that it really means. And to attack this problem, I'm going to go ahead and write this problem in this terms. Otherwise, what I'm going to do just isn't going to make sense. Okay, now I'm going to use my even-odd properties to deal with those negative signs in front of my variables. Okay, those are not going to work well for us at all. So our tricks of getting rid of those is we're going to use our even-odd properties. Now, sine is odd, so I can take that negative sign and pull it out. Cosine is even, so I can forget about it entirely. Okay, so negative sine theta times negative sine theta is positive sine theta. Cosine theta times cosine theta is cosine squared theta. That's one of our identities. Sine squared theta plus cosine squared theta is equal to 1. So, yeah, all that garbage reduces and simplified. 1 does exactly equal 1. Okay, a little bit too rudimentary. Let's get into something just a little bit more complicated. All right, so we're going to establish this identity. Now, what we learned in class today is this is actually, look at this denominator. You could even actually look at the numerator. This is actually a very good candidate for a conjugate. Now, I tried a conjugate of 1 minus cotangent theta in the denominator, and it was a train wreck. You might want to apply 1 minus tangent theta as a conjugate. It might work out. Okay. That might work. But 1 minus cotangent theta was a train wreck. Okay, so what are we going to do as an alternate strategy if that doesn't work? Okay, well, I always like to put things in terms of sine and cosine if possible. So that's what I did. All right, now what we're going to do next is we're actually going to perform this addition of 1. And that's kind of the purpose of this problem and its demonstration. Now, what I want you to notice is the 1 in the numerator expression and the 1 in the denominator expression, I set it up to add. So if you'll recognize, this guy is the same thing as this guy, right? But all I've done is I've given him a common denominator. Same thing I did here. I took that 1 and I said it was that. And why did I do that? Because it gives me a common denominator with that guy. That allows me to actually perform the addition. And at first it looks messy. But there's the addition. There's the addition in the denominator. And now the next move, things come together real nicely. Okay, so what am I going to do? I've got 2 rational expression. Rational expression just means a fraction-looking thing. And how do I deal with a division? It's the same thing as multiplying by the reciprocal. So that's what I'm going to do. I'm going to perform that division by multiplying by the reciprocal. And then you should see the next move. Those guys are going to cancel. So I end up with just a sine over cos. I say cancel. That's not really true. Divide out and make 1. All right, and then sine over cosine is simply the tangent. I did establish this identity. All that icky garbage that we had on the left side of the equation does indeed just equal tangent theta. All right, let me see if I want to do this actually. Nope, the next one, this is going to be an example that we're going to do in class. And now what the heck? We're rolling. Let's go with it. This one works quick. Let's foil this together. Oh, I didn't even do it. Never mind. We're going to do that in class. All right. Thanks for listening, y'all.